All right. Awesome. Enough talk about Las Vegas. Hey everybody, I'm Sean Knopp, and I really want to spend some time talking to you guys about impact engineering. We have a pretty small group here, so we can certainly make it intimate. You can hide in the back if you really want, but you'll probably get more out of it, definitely when we get to some of the questions. Quick survey, just so I can help tailor a little bit of this to you all. How many folks are managers or leaders of data organizations? Okay, we got a couple sheepishly raising their hands. How many people directly hands-on build data systems, software systems? All right, so that's really interesting too, because everybody who's like, I build stuff was very confident in raising. Everybody's like, I kind of manage very sheepishly. Nobody's gonna like kick you out, nobody's gonna beat up on you. But I do wanna spend some time talking about what I'm really passionate and excited about, which is how do we create high impact engineering teams, both for software engineering, but also for data engineering itself. Quick bit about my background. I started my career 19 years ago as a geeky software engineer. Ended up building out and leading Google's first front-end engineering team for web search, which was a very accidental way in actually becoming a data engineer. Fun fact is when you get to go push pixels on the world's largest web property, you also get to run really large data pipelines to analyze the efficacy of said pushed pixels. So I ended up writing a lot of MapReduce jobs really early on in my career, just getting to analyze the various experiments that we built. Over the course of the last 19 years, I built one startup up to about a $400 million exit where I was the CTO and ran a 250-person engineering organization. And then more recently have started the company Ascend.io, which you'll see our logo here, really focused on how do we introduce higher levels of automation into the data engineering landscape. Not going to spend too much time today talking about Ascend, however. We are going to spend a lot of time talking about the domain of impact engineering that I think is a really important topic and very key to how we in the data ecosystem today drive outsized impact and success for our teams, whether we're hands-on building our own data products or whether we're leading teams and trying to construct the right culture for those teams to be highly successful. So, general agenda that I want to work through. First and foremost, I want to talk about what does it really mean to have impact engineering, and what is it going to mean for you and your teams? Second, we're going to spend some time talking about the innovation lifecycle and why that matters so much. Third, I'm going to talk about why it matters now and why this isn't as interesting of a topic, say, 2 years ago, but I think is incredibly critical and key and interesting today. Fourth, I want to give you all a little bit of techniques for success for both those who are our ICs, who are directly building on the product and how you can propel your career, but also for those who are leading teams, how you can help those teams be really effective and successful as well. And then last, I'm going to talk a little bit about how we just apply this to the data engineering ecosystem. I'm going to spend some front-loaded time on what are the core principles that can really be applied, whether it's a software team, a data team, or pick your other said favorite profession. There's a lot of conversation that's been had over the past around what it means to be a 10X or 10Xer. Are you a 10X developer? Are you a 10X individual? Are you a 10X team? We're not going to spend as much time on that because I think there's many different ways to find success, and the opinions in this presentation are mine and mine alone. There are many other ways to be successful. I'm going to mostly highlight the ones that we found that are really effective at Ascend and that I found over the last 15 years of leading software and data teams. So I want to be very transparent. Plenty of other ways to be successful. This just happens to be ours. All right. First key topic I want to talk about is when we think about impact. More often than not, the most common misconception I see with teams and individuals is what it means to drive impact. And the most common confusion is that between activity and outcomes. Most folks generally orient their definition of impact and purpose and driving for activity versus outcomes. I think that's really important to separate. And there's a lot of tricks that I'm going to share later that we can really help ourselves and our teams to focus not on the activity that we're doing, but rather the outcome. And the reason why I think this is so incredibly important is, simply put, if anybody had a previous career in finance, activity is cost. It is cost for you, cost for your company. It is you spending hours regardless of whether or not there is value created. Outcomes are revenue. Regardless of, as oftentimes as technologists and engineers are like, oh, revenue, like that seems like bad. We're not supposed to talk about money. We're just supposed to talk about like making an amazing product and let people be just delighted by the outcome of those products. But the thing is, users and customers generally vote with dollars. And if they really like the thing that you're building, they're probably going to pay for your service or your product. And that really becomes the ultimate measure of what matters. And outcomes drive revenue for your business. And I think this is a really important thing to stay focused on. So against some of that backdrop and structure, I want to talk about the innovation cycle and how things tend to traverse over the course of time. And it's something that I've been spending a lot of time on in the last 5 years, both watching the engineering culture inside of Ascend, but spending a lot of time with other companies that I either advise or invest, and watching them struggle with the same life cycle of innovation and where their teams tend to focus their most valuable time and energy. And so when we think about the innovation life cycle, this happens in not every industry, but actually every subcategory of every industry. And it's a never-ending cycle, and I'll walk through that in a little bit. But we tend to see these 4 same stages happen over and over and over again. And over the course of time, you'll start to zoom out and you'll realize the same patterns emerge. It doesn't matter if it was software or data or analytics, the same cycle happens just against a different backdrop. And it always starts with some core innovation. Small group of individuals do something really amazing. They create Spark, or they create Hadoop, or they design something like a Delta Lake. And what you start to see is those patterns emerge, and really quickly, because of the potential of that new technology, that new architecture, that new design, you actually see this gold rush. So everybody sees that value. Like, oh my gosh, this is the coolest thing since sliced bread. We have to find a way to take advantage of it. And from my perspective, it is like the coolest form of just like sheer and utter chaos. It's just like, everybody's like, I don't know exactly what we're doing, but we have this cool new thing, this like the best hammer we've ever found, and we're gonna go find everything and make it a nail. And you just start to like run all over the place and use it. And it's great. It's like this mass level of inefficiency from a macro perspective, but it's how the ecosystem generally finds its way through to seeing where you really get unique and outsized value from something. And it's really fun to watch. It's very wasteful. Most economists would be terrified by this stage of innovation cycle, but it's a necessary part of the process. What ultimately starts to happen in any domain, you start to see standardization and consolidation. The best practices emerge. Somebody figures out like, hey, if we do it this way, it's gonna map to 95+% of the use cases, we're gonna publish it, we're gonna release a framework, we're gonna build a tool on top of it, and you start to see people coalesce. And this is great, because what happens then is, to achieve the same things you would need to from an outcomes perspective in the previous era, you can now do with probably half as many people. And that's awesome, because then the other half, you can get to go do other really awesome stuff, and they can stop spending their time on the inefficient things. And really where we ultimately like to see things settle and stabilize is in this productization, automation category. That's an amazing place to be, because then a single person can do really awesome, impactful things. And that means those 12 people you had before can all go do really awesome, impactful things, 12 times as many, hopefully, as you could before. And it's a really amazing outcome. You know, I remember when I started my last company, and this was in 2008, and we're running our own Hadoop clusters, and we're racking and stacking our own hardware, and we're just grinding our way through to do all the stuff that we used to be able to take advantage of back at Google. And man, was that so painful. And then Spark came out, and then we did the same thing with Spark, and we spent all this time and energy trying to run our own Spark clusters. And now, I can literally just go swipe a credit card and buy the Databricks stuff and be like, this is fantastic. We can go work on the higher level stuff. And that's amazing because it's such an impactful accelerant for the business. Now, the reason I want to focus on this a little bit too is I've been hard-pressed to ever find an engineering team that actually likes this notion of productization and automation. And we have this natural aversion to it. And it's a very, very natural aversion because we as engineers are innovators. And we want to be the ones in the lab doing the really cool stuff and pioneering. And it's true, we can do amazing things when we get to put our intellectual horsepower to innovating. And when we think about automating, we think about, oh man, you're going to put me on like the assembly line of software engineering and I'm just going to get automated away. And that sounds like a pretty horrible future. And as I spent a lot of time with data engineering teams and software engineering teams, this usually starts to come out. Maybe not even directly and overtly, but you certainly see it in some of the conversations that emerge. And I think this is kind of a sucky bias, I would say, in the industry. And I'll explain a little bit why. But one of my goals is to really encourage teams to embrace productization, to embrace automation, as it lets you achieve really neat things. But first, let's click into a little bit more of why do people resist? For me, as somebody with multiple software engineering degrees who invested many, many years of his life and career learning out how to build things, I'm an artisan. I have a craft. You can't automate me. I don't want to be on the right. I'm on the left side. I can do really cool, creative things. My wife still jokes, on a weekend when I get time and free time, I'm not doing board slides or other fancy modeling. I'm like literally in a code terminal just creating something. Like I'm trying to automate the home lighting system, or I'm like writing something new to run on some Kate's cluster that does really nifty auto-scaling of whatever. Or I'm writing multi-tier caching systems for Docker containers, which was last Saturday. But like, I like building, and that's actually part of the identity as an engineer is we get to create things, and it's fun, and it's magical. And so we see this natural resistance to this notion of productization and automation. And it just happens inside of engineering orgs. I'm going to double click into why a little bit more. But I think this is dangerous when we put this on a single trajectory, when it's a single path, because it's far more complex than that. And when we think about it as just in any field, we're moving from innovation to automation or innovation to productization, we set ourselves up to be this guy. I don't know if anybody else is old enough to remember Gary Larson cartoons. But you end up being the really smart guy in the room pushing the wrong direction and you're just not paying attention. And you have all this potential and all this intellectual horsepower, but you're just not reading the environment in the room. And I think that can be really, really risky because you're putting all of that potential and weight behind the wrong thing and pushing the wrong direction. And so what I'd like to suggest is that it's actually not a monodimensional evolutionary cycle, but it's actually a multidimensional, or at least a two-dimensional evolutionary cycle. When we think about where we invest as teams and as individuals, it should actually be against this backdrop that there is a constant evolution, a constant progression up stack. It's actually one of the things that gets me really excited as both an engineer and as an engineering leader is that it's always changing. I love the opportunity to go jettison all the stuff that we did before because it frees me up to go solve the next cool and exciting problems. And so what usually happens in a space is we start to find this tremendous potential to move up stack. And this is one of the things I really want to be able to plant the seed for with people is when we choose to innovate, we should be looking for how high up the stack can we innovate. Because if we choose to innovate deep in the stack, if you're trying to move back on-prem or run your own Spark cluster or do your own storage layouts, man, are you encumbering your ability and your capacity to innovate higher up the stack where it's really going to matter and where you're really going to be able to affect outcomes. And so one of the things that we certainly practice at Ascend is how do we actually push higher up stack? What can we delete? What can we get rid of? We celebrate deletion and deprecation of existing systems and technology more than we celebrate the creation of new ones. We like, yes. For us, it is freedom. It means when you get rid of something and you say, wow, I can swipe my credit card for the thing that I just built like 3 years ago. One, that's an incredible alleviation of stress because you're probably not going to get paged in the middle of the night for it not working. But two, it frees you up for so much more that you can do because you don't have to worry about that hangover from your previous investments. So let's talk a little bit about why now. Because I'm certainly not the first one to have these thoughts or probably talk to you guys about this. But why I think this matters so much right now is a fewfold. We're in a really interesting point in the industry. I think we're far from being done with the current market conditions. And we see that 70% of companies today have or are planning on implementing a hiring freeze. 61% are likely to or have already done layoffs. This is really, really scary. Because what happens historically as technology companies and teams, we tend to rely on our ability to grow our headcount to keep our innovation curve ahead of our debt curve. It's just like baseline economics applied to people. The second you stop hiring, your people get to keep building, but at some point, your productivity will asymptotically approach zero. Every line of code is another line of debt and deficit that you have to deal with. And over the course of time, things will slow down unless you radically change how you approach. And what we're seeing in the current market is the ability to simply throw more heads at it is disappearing for most companies. And so you have to rethink your approach to how you're going to get extra capacity. And even if you do have the ability to hire, there's still not enough of us to be able to do it all. So you're still probably going to have to find somebody from adjacent spaces and train them up on the skill sets as well. So this is where I do like to try and shock the system a little bit to get us to think more creatively around how do we get our teams more leverage. To put even more fuel on the fire here, every year we run a survey of data teams. We've got about 500 anonymous folks, not assign customers because they're too biased. We just ask them basic questions like, how's your day and your capacity? Really basic. Are you at capacity? Do you have breathing room to do more things? Or are you underwater? And 96% of teams, or actually of individuals, say, we are at or over capacity. We have no time to make new incremental investments. 93% of them say demand for what they're doing is increasing and they need to build more data pipelines and more data systems than ever before. And 74% say it's still growing faster than their team's capacity itself. So this only further compounds it. Beyond the macro market conditions, in the data ecosystem in particular, it's even rougher. So I think these are really sobering things for us to think about around how do we actually get greater leverage for our teams. All right, enough of the problem statement. Let's talk a little bit about what we can do about this. One of the guiding principles that we use internally at Ascend, and that we certainly work with a lot of our customers and encourage them to do as well, is try and maximize the impact per hour invested for every individual. I'm going to double click on this because you're going to find it's a little bit contrary to what you'll hear from other folks. And as I mentioned before, there's many ways to find success. I'm not a big believer in the structure that you actually need huge teams to do incredibly large outcomes. I don't think that fits for the majority of use cases. Certainly hasn't mapped to my experience. And so when we think about it, we want to maximize the impact for each and every single individual. Every person on our team, I want them to, per hour, be able to create as much value as humanly possible. And we try and optimize everything from our architecture, our code, and our culture around that. One of the key design principles that we have on this, individual impact goes up when the number of people required to deliver a result goes down. The panacea is a single person with enough context can get the job done. It's hard, like really, really hard. But when you can do that, the person is empowered, they are enabled and equipped, and they can do tremendous things. They spend less time in meetings, less time coordinating, more time coding, and more time delivering outcomes. What we do internally, and this is a really big one, you need a user and customer-oriented mindset. It gives meaning. If you don't know why you're doing what you're doing, you generally start to find roaming projects. I can't tell you how many projects in my history I have been presented where I always ask two fundamental questions. Why does it matter? What's the break even? Because until we at least hit the break even from hours of productivity or input or cost, you're asking me to loan you something. You're asking the company to loan you time and energy and resources and forego opportunity to do something else. And these we found as we weave these into our culture are incredibly impactful because everybody asks it now. Like, hey, I got a proposal. We should do X. And they start to do the math. They're like, actually, that would improve our productivity, but really the break even's not going to be for like 18 months. Like, nope, that's not going to make the cut. Let's figure out something where we can get a break even in like 3 months or less. And what we find is when we focus on the impact to users and customers, that becomes the first orientation because it then keeps us oriented around how do we create value for them. The second one is empowerment. I am a really big believer in building a culture of polymaths. We work really hard to educate everybody in the company across the stack. They learn multiple languages. My classic coaching to every new grad a year out of college, the 1-year mark is always, now is the time for you to shift from reactive learning to proactive learning. For probably the first time in your career, you're going to have to go from just reacting to the information that you're exposed to proactively asking why and just keep digging deeper and deeper. Because generally you don't have to do that in high school or college or even the first year or two of your career and probably the first 6 months of a new job. You just get to react and learn. So part of what we push as part of our polymathic culture is go deep. Keep asking why. Ask why all the way to the point that you're annoying and then ask a little bit more. But you're going to build up this tremendous knowledge and culture. The next thing that we do is we do spend a lot of time looking for opportunities for step function advancements across the company. The really basic one, and I did this mostly just to be annoying, is, well, of course, you just look for the things that are like really cheap to do and create a lot of value. How hard could that be? But it is more complex than this. And so in reality, what we do is we run a thought experiment and look for these outsized 10x improvements across the team and the company. And so this is a really fun exercise. And anybody who's been through a similar exercise, I really hope it was successful. But I always got to preface, you got to set the ground rules. Because it's really natural to be cynical about these and to resist. I did the first time I was exposed to this. But with consistency and patience and creativity, it's actually a really fun exercise. So the way the exercise works, we ask the question, what if we had to double the impact of our team without growing our team at all? And you cannot work more hours. As a manager, the last part's probably the most important because otherwise you're just mean. You're like, well, if we just work twice as many hours, or probably 2.2 as many hours, I'm sure we could double our productivity and our impact. But honestly, this is a really interesting exercise. Has anybody ever run an exercise like this inside the company? I have a feeling if you ask most people, they'll be like, this is such a waste of time. You might actually be thinking that yourself. Hopefully not, but the general reaction I get at first from most people is like, this is a complete waste of time. Can't believe we're spending time on this. Like, it is not possible to double the impact or double the productivity without increasing the hours or increasing the heads. But the reality is you'll usually end up with a couple of people who will come back a couple of days later. And they're going to actually have an idea. They're like, I thought that was total BS. And I just wasted 4 freaking hours yesterday on this. I'm like, all right, say more. Let's unpack that a little bit more. And you'll start to find that you can actually start to get more and more details around the areas where you start to waste a lot of time. And so I'll give you an example. Just recently, we announced really cool product offering for our customers. 100% free ingest. Databricks user can tap into a library of 200 plus connectors, and you get free ingest into Databricks. We managed to launch that very quickly. We can do it pretty easily, too. Impactful for our customers and our users. Sales team loves it because they just can go walk around conferences like this and be like, do you like paying for ingest? Guessing not. And we're able to do that really impactfully. And it stemmed from this exercise that we ran. We said, well, man, back in the day, 2 years ago, it used to take 3 engineers, 2 weeks, and well over 1,000 lines of code across 4 different languages and 4 different microservices to launch a single connector. Like, oh, how the hell are you ever going to get to 200 connectors? We took a step back. We said, well, you know what? We should actually redesign that. They all follow the same pattern. Took us about 2 months with 2 of the senior engineers to redesign an entire framework for the connectors. We actually found an amazing partner. We work with a company called Data, who does the last mile. They give us a wonderful little jar. Well, actually, they give us 200 wonderful little jars that we can embed into our framework. And because we run on Spark, we can easily embed those jars. We have all this intelligence in our product that can sit around and make those connectors incredibly smart, incredibly powerful. But by redesigning that, thinking creatively, finding an amazing partner, we freed up tremendous capacity for our engineering team, and at the very same time, created a huge amount of value for our customers. So let's talk a little bit about how we apply this to data engineering. As a reminder, a lot of the name of the game is figuring out where do you want to invest? What are the things that are really unique? Should you be tuning and optimizing Spark clusters? Should you be working a little bit higher up stack? Should you be worrying about storage formats? We're at this amazing time where we see all this great technology becoming not just emerging, but actually becoming fairly standard. We've moved everything onto Delta. We have this amazing format. It hybridizes lake and warehouse, aka the lakehouse approach. We love the capabilities of this. It means we don't have to do all these other things we used to have to do. We had a really nifty, fancy, smart storage thing that we used to do as part of our product. Took tons of engineering time, was one of the leading causes of bugs and pain points in everybody's butt, and we just don't have to deal with it anymore. It's fantastic. We got to delete so much code. Everybody's so excited. Similarly, we used to spend tons of time tuning and optimizing far more on how we ran the SQL queries and the clusters that ran them. We love using SQL Warehouse. For our Databricks customers, now, the SQL Warehouse is the standard recommended model for all SQL-based transformations. Performance is amazing. We don't want to have to try and do all these other smart, nifty things around optimization. Let's just build on top. Similarly, we do deep integration now with Unity Catalog. We used to try and do all these other fancy things with Databricks customers, and it was just a pain in the butt. This is the Ascend product over here on the left side, if you're just curious. But now it's much easier, and it's much more seamless. These are like the common things that we now see full standardization and productization around that we always recommend for folks. The last piece that I'll highlight, and preface this, clearly in a domain that I'm biased and very passionate about, as this is where Ascend also focuses. We think the next area that's super ripe for disruption and actually for productization is really data pipelines. Every time I see a data engineering team, they just look like this to me. I used to have a 60-person data engineering team, and it just looked like 60 dudes and dudettes like that. It just feels like chaos. And I feel like the realm of data engineering in general has become a badge of pride to be like, yep, like all my DAGs are intertwined, and I got paged at 3 a.m. again, and we all kind of sit around the barn like, yep, I've got paged at 3 a.m. again, that was cool. And it just doesn't scale. I feel that as we continue to invest, we see all of the capabilities that have been productized continue to propel us up stack, but it means we have more people building more pipelines that are all interdependent from each other, and the complexity and the risk of those systems goes up exponentially. Yet we haven't seen great productization around how we run these. And so when we start to think about where that should really take hold and why that matters and the benefits, there's a ton of things we can do once we get more productization and automation around how data pipelines work. As we did a lot of the academic research early on around what are the problems we see and where can we add tremendous amount of benefit, it's in the stability, the reliability, the efficiency, the cost efficacy of data pipelines. This is where we still see so many engineering teams spending so much time building What are these highly imperative data pipelines? You're spending vast majority of your time on state and recovery logic, not on actual data logic. We find it a really, really brittle kind of ecosystem. For me, with more of a software background, to me, this reminds me a lot of back in the day when we spent all our time on Chef and Puppet versus Terraform, or random actual server orchestration versus just being able to run on Kubernetes. Academically, we find that move to context-aware, domain-specific control planes, not just declarative systems, but actual intelligent, continually running declarative systems, enables us to do these amazing, really fancy things. And so this is one of the areas where we're really excited. And I'm not going to deep dive too much into it, but I almost always get a question of like, well, how does that actually work? And how do you do these? So I'm going to give you guys a teaser, and then I'll go answer some questions. How you do really fancy stuff like this, and how you can automate, in case anybody ever wants to go build their own. If you happen to work for an Ascend competitor, this is the blueprint. Just go copy this. Took us a long time, but go for it. We do really nifty stuff. If you want to build a declarative system, but that is actually continually running, continually optimizing, domain-specific, we have really fancy technology. It fingerprints the code, and it fingerprints your data, and it binds the two together, and it tracks the entire lineage. When your code changes, when your data changes, we know the entire trace of lineage, not from a logical perspective, but from an actual physical partition by partition layer of the data that is actually affected by a change. A delete, an insert, an update, and as a result, we know everything that is affected by any change in data. So when you have a data pipeline, when you push new code, we know what happens. We know the ripple effect. We can actually optimize for that because we can quickly and easily detect fingerprint mismatches. There's like the one class I barely paid attention to in college was like cryptography, and then it came back 20 years later like, might need to go refresh that course online. But SHAs and fingerprints are really impactful, especially when you're trying to do rapid change detection. Once we do that, we're able to really easily detect those changes. We do that because we maintain these massive maps. Because we have all this metadata about all the data that's moving through the system, we simply generate these blueprints. We generate a blueprint of SHAs, what should exist, what does exist, diff the two, and then all of a sudden you have a playbook for what do you have to actually do to go generate work to run pipelines. It's a really different approach that is incredibly powerful when you think about how data pipelines work. Classic orchestration, where you're checking the state, what was run before, trying to figure out what you need to run again, too brittle, too broken, too error-prone. Whereas this, with an automated system, is just in a continual state of integrity checking. Constantly analyzing code and data and changes in those and figuring out what is the minimum amount of work that's required to make sure that you have the exact right data running through the exact right code and fulfilling that model. And the system's really simple from there. Just propagates. Life of a control plane is very high anxiety. You're just constantly looking for breaks and trying to fix it, basically from a blueprint model. But it becomes really, really effective. So I'll happy to answer more questions on that, but when we start to think about really this potential for high impact engineering, especially in data engineering, this is where I see the vast majority of teams spending the vast majority of their time. And I think they should stop. I think they should go spend their time on LLMs or other really nifty stuff and stop doing the plumbing. But to quickly give you all some reminders before I answer any questions, first and foremost, when you think about high impact, define the impact for you, your team, your company, you as an individual. Hopefully they all align. If not, should probably fix that. Second, be really intellectually honest with yourself and your team around where you are in the innovation cycle across all dimensions. It's really easy for us, and I get it, like to say, we're in the innovation era for this. And the reality is 9 times out of 10, you're probably not, and you should push yourself up stack and go innovate up there. That's generally where I've seen the highest impact be generated. Third, especially now, act with a sense of urgency. I think the debt curve is catching up with most teams. Most teams are finding their productivity is dropping. You need to do something soon and fast before your capacity approaches zero. So you got to be able to dig yourself out and create more capacity before you no longer have the ability to do so. I've sat on too many boards and run with too many heads of engineering to hear the story play out where, now we need to actually radically reduce our entire product delivery strategy because we're gonna have to spend the next year now re-architecting. And it's never a year, it's always 2 or 3 years is what it ends up being. Don't get stuck in that trap. Figure out a way to start to incrementally increase your capacity now. Fourth, create a culture that provides context and empowerment. One of the things you'll notice, we bring the entire engineering team at Ascend to conferences. We want them directly spending time with our customers and our users. It's awesome. We're all just a bunch of geeky engineers at the end of the day. Like, it's way cooler than going to like a media conference, which was the industry I found in my last company in. Like here, we just get to hang out with other geeky engineers. It's fantastic. We love giving people access to that because it creates this context. Fifth, focus on those areas of outsized inefficiency and waste. It's really easy to get distracted by small incremental things. Hold the line. Find the things that really profoundly move the needle because that's what creates capacity for the next. And then last, be cognizant of what is coming next. Don't think just about where you are today, but as Wayne Gretzky loves to say, right, skate to where the puck's going. You got to be able to intercept those curves. Even if something's not quite where it is, like you're so much better off if you can intercept that curve. You'll get so much more impact out of the team. All right, cool, y'all. We got 3.5 minutes. Thank you for the time. Any questions?